Welcome back, class. Today we're going to be talking about constructing a frequency polygon. Now, whenever we're dealing with frequency polygons, you have to realize that we're dealing with two different types or two different flavors of frequency polygons. The first is the simple type, which we just call frequency polygons. The second type is called a cumulative frequency polygon, but either way it goes, we're going to need a frequency distribution to begin to construct these polygons. Okay, so you should have the data. Maybe you took some raw data, you processed and organized it, and now you have a nice grouped frequency distribution table. Okay. Once you have that table, we need to understand first what a frequency polygon is before we start constructing it or modifying our distribution table. So the first thing we have to understand is that a simple frequency polygon is just a graph that's going to display the data using lines that connect points, plotted for the frequencies at the class midpoints. Now, that's kind of a mouthful. What you have to understand is that this frequency polygon is very similar to a histogram in concept, but maybe not in the way it looks. Its shape is a little bit different, okay? So in the same way that a histogram measures frequency as the height of a set of vertical bars, what we're going to do is calculate these midpoints for each of our classes, and then the point that we create is going to have an x value at the midpoint for each class, and the height or the y value of that point will be set by the frequency. Okay, so the first thing that we need to do is modify or extend our frequency distribution table to include our class midpoints. Okay, so you can see here on the right, I have created a table where I have some class boundaries, and I've already calculated the class midpoints. Presumably, we already have counted up all of the raw data, and we have our frequency distribution also. Okay, so how do I calculate class midpoints? Well, it's very simple to do. You just need to add up the lower class boundary and the upper class boundary for any of your classes, and then divide that number by 2. So for instance, if we look at this first class we have here, 99.5 plus 104.5, and divide that number, whatever it is, by 2, you should get 107. For the second class, you'll do the same process, 104.5 plus 109.5, divide that number by 2, and then you should get 107. Okay. So again, in the formula here, LB represents your lower class boundary, plus UB, which represents your upper class boundary, divide that number by 2, and that is your midpoint. So once you have all your midpoints here and you've appended that to your frequency distribution table, we can move on to the next step and actually construct that frequency polygon. Okay. One other note that I might make really quick is that if you do not have the class boundaries, that's perfectly fine. You can also use the class limits to calculate the class midpoints instead. So like I said, once you have the midpoints, those are going to represent the x values for our points, and the class frequency is going to represent the y value for our points. Okay. Once we have those points plotted, it will just be a bunch of floating dots in space, but we will then connect each of the points with a straight line, and then make sure that at the end of our graph on the left and right side, that we anchor our polygon, whatever shape that happens to be. We anchor our polygon to the x-axis. Okay. So I think that maybe running through an example from the homework platform is going to be really helpful. So let me go ahead and share that screen with you guys so that we can run through an example together. Okay. We should be seeing this problem from the homework platform, which is very similar to the example that we just came across. Okay. So let's go ahead and jump into this problem and read the instructions. This one says, the frequency distribution represents the cost in cents for the utilities of states that supply much of their own power. Construct a frequency polygon for the distribution. So as we saw in our previous example, we know that we need to compute the class midpoints for each of our classes. And right now we're given class limits, not class boundaries, but that's not a problem, okay? What we can do here is go ahead and begin to find those class midpoints. So if I take this first class here, and I take 6 plus 10 divided by 2, I know that's going to be 16 divided by 2. So our first class midpoint should be 8. And what do you know? 8 is featured down here on the x-axis of our graph, okay? And don't mind the annotations here. They're going to sort of wiggle around as I scroll up and down. But the main idea is that we need to find these midpoints so that we can plot the frequency at the correct location. Now, the homework platform, let me go ahead and erase these. The homework platform will allow you to plot this point in one of two ways. The first way is to simply click and drag this point up to the frequency value that we need. And you can see already that I'm going far too high. That first class at that midpoint needed to be plotted at a frequency of 2. I'm just going to move that to 2. That's one way to do it. Let's do the next one. We know that 11 plus 15 divided by 2 should simplify to, we'll have a 6 there. We'll have a 2 there. It should be 26 over 2. So we're looking for a midpoint of 13. And sure enough, 13 is featured in our graph. Okay. So that means we should now either grab this point and drag it to a frequency of 3, or you could simply type 3 into the little box that it gives you, click away, and it will plot that for you. Okay. So as you go through this process, you will find the midpoints here, and then plot the frequencies. So the midpoint for 16 and 20 should be 18, so I'm going to plot 4 here. The midpoint for 21 and 25 should be 23, so I'm going to plot 8 there. The midpoint for 26 and 30 should be 28, so I'm going to plot 10 there. The midpoint for 31 and 35 should be 33, so I'm going to plot 2 there. And finally, the midpoint for 36 and 40 should be 38, so we'll plot a frequency of 1 there. Let me go ahead and erase these annotations. And this is what our frequency polygon should look like. Notice that we didn't actually have to anchor the polygon to the x-axis ourselves, because these little categories that they have here, these unused midpoints, if you want to think about it that way, these unused midpoints are already anchored at the x-axis and have a value of 0. So we don't have to touch those at all. And now we can just check our answer. And you can see that we got a green check mark indicating that we got that one correct. So that's how you go about calculating the midpoints and constructing your frequency polygon. Hopefully that example is very helpful for you. We will, in the next video, go ahead and figure out how to construct that cumulative frequency polygon.